This is the exam 2. I'm explaining Huffman encoding. Huffman encoding is a data compression technique. Data compression technique is really very useful in while transferring data from one system to another system through a network. Where if you want to transfer a data from one system to another system, it needs to be transferred through a network. Each character in the string requires some space to some kind of packet size to transfer. So it has to take the ASCII code for every each and every character, whether it's a number or a character or symbol. It needs 8 bits, so it will require a lot of space packet size to transfer in the network. So here, if you, for example, there is a sequence given here. There the total number of characters is 20. In order to 20 these, in order to transfer these characters through a network, it requires 8 bits each. So in total, we require 160 bits in order to transfer these. I'm Huffman encoding will compress the will compress this character string, and it require and uses less number of bits to transfer. Now we'll see how this Huffman encoding is compressing the string, and with by using some Huffman technique, how we can compress the number of bits. See, for example, I have taken this character array. This character array has in total of 20 characters. First of all, we need to count the all the characters. There are 4 different kinds of types of characters are there: A, B, and E, and W. We have to count each character. Here A is repeating for 12 times. That's why we have taken the count as 12. B is repeated for 3 times. All the count of each character has to be taken and noted down in in the form of a table. Suppose here we need to calculate the code for each. In order to calculate the code, we have to build a tree first. Suppose we have to write these base level, the leaf of the end level of the tree first, and from there we need to build the tree structure. Suppose I'm using all the characters to W, B, E, A in the ascending order. So I have taken the 2 first. Here by adding the 2 and 3, I'll get 5. How there is many other options. We can add these 2 and 3, the character of W and E, or else A and W. Here how we can get the where we can get the minimum value, we have to choose that. Suppose I am getting the minimum value for adding 2 and 3. By adding the 12 and 2, we'll get the maximum value of 14. If we have to compare the 14 and 2, so 5 is the minimum sum we are getting here by adding the count of W and the count of B. So we are getting the 5 here. In the same way, we have to repeat the same process for all the remaining characters in the tree. Here the 5 and the 3, the 5 3 and the 5 12 has to be compared. The 5 3 sum is 8 and the 5 12 sum is 17. So if we compare the 8 and the 17, we can clearly say that the 8 is the minimum value. So we have used the 8 as the parent, and again we have to repeat the same process. There is only one character A is remaining with count 12, frequency 12. The frequency of these and this parent is 20, so that we can give it we can add these the remaining 2 and the parent will be 20. Now we have to calculate the code from the build tree. Suppose if you know binary search tree, the less number of values will be on the right side, and the will be on the left side, and the greater values than the parent will be on the right side. In that way I have considered, and all the left hands of the tree is assigned with zeros, and the right nodes will be assigned with ones, so that I have assigned 0 for all the left hands, and the 1 is assigned to the right hands. So how now the question is how to calculate the code. Suppose for binary search tree we have to start from the from the parent, and we need to, if you want to search any node in the BST, we have to go through parent. In the similar way here also we have to start with parent. The parent is 20. Now we want the character A. The character A count is 12. So here if we come from the parent, we can go to 12 with the count 1. We can directly go to the 12 since there is no any intermediate parents or leaves there. The A is directly connected to the parent. So we can consider the code of the A is 1. And for if you want to go to the B, then we can say that B is here. From parent we can traverse to the B. There is 0 0 1 through the path of the traversing is 0 0 1. That will be the code for B. So I have noted it as 0 0 1. If you want to traverse to E, we can traverse with 0 1. The path of the E from the parent is 0 and 1. So I have given it as 0 and 1. For W, it will be 0 0 0. So I have given it as 0. Now we get the code value also. We have to calculate the bits required for each character. Here the I need a single bit in order to transfer this A. There are 12, frequency of A is 12. So I need in total of 12 bits to transfer the character A, all the occurrences of A. And for B, there are the frequency is 3, and I need 3 bits to transfer. So 3 into 3 is in total 9 bits is required in order to transfer B. In a similar manner we will calculate for E and 2 also. E requires E code has only 2, that's why, and the frequency is 3, that's why we require 6. And W is also 3 2 frequency, which requires 3 bits each, so we require total 6 bits. In total if we sum all these value 12 9 6 6, we'll get 33 bits. Now we'll say all these sequence of characters will be sent by using 33 bits. Now we have to share the table also. The bits required in order to share the table we need to calculate. For these 33 bits are only to transfer these characters. In order to get these code, we need to transfer this tree and the table. For that we need to calculate now. If you see the size of the table is in total, if we calculate here 1 2 3 4 5 6 7 8 9, it requires 9. The total number of bits for all the characters is 9. That 9 has to be taken, and the number of characters is 4. And for each character we need 8 bits. As I told in earlier, each ASCII value requires an 8 bits. So 4 into 8, and these codes are 9. If we add that, we'll get 41. In order to get the total value, we require the sum of the size of the table and the bits, the sequence of the characters. So for the total size we required is 74 bits. If we transfer the this character array without using Huffman encoding, it requires 160 bits. Since it has the 20 characters and 8 bits for each character, it requires 160 bits. So because of using Huffman coding, we are compressing the data. Now by using only 74 bits, we can transfer the data.